So to keep it the same as this diagram here, it's starting in N2. And notice that this only works if this object, if the material, the medium that it's starting in, has a higher index of refraction than the medium it's going to. Because this number then will have to be larger than that number. So N1 over N2 will have to be less than 1, which is the only way that this answer will make sense. If you try and find the arc sine of 1.7, your calculator is going to look at you, look, you've gone crazy. Now, let me clear a bit of this space. Actually, let's say that I've got then some object, and it's going to be giving off light at those different angles. Let's see. Obviously, if I have, the light going through that's normal to the surface, that's not deflecting. Light coming through at an angle will be deflected, and if N2 is greater than N1, it'll be deflected farther away from the normal. And as I get farther away, then the angle of incidence is going to keep getting larger, and then the angle of refraction is going to keep getting larger until I get to this critical angle. But notice what's happening. If I were to be looking through, wandering through space, all of these lines meet at some point. So if I've got some object distance s, the object doesn't look like it's at object distance x. It looks like it's at a different distance away from, the top of whatever that second material is. So I'm going to call the image distance. That's why if you just take, for example, you put like a layer of water or a glass plane over something, or a block of glass over something that's too small for you to be able to see, it can look like it's having a bit of a magnifying effect because it's taking the image and bringing the image closer to your eye. If I take a look at that, I can see that image distance using a little bit of geometry. I have that, okay, this this angle is the angle of incidence. Because these two lines are both normal to the surface, at least as I've drawn it right here for this flat plane, that angle is also equal to the angle of incidence. Go back through your geometry and double check to see if you're willing to buy into that. Now, if N2 is greater than N1, so it's bent farther away, the angle of refraction will be equal to that angle, because they are opposite angles. I've got two straight lines intersecting. Opposite angles are equal. And in the same reason that these two angles of incidence are equal to each other, hey, the same straight line hitting two parallel lines, these two angles of reflection are equal to each other. So, if I look at these two triangles right here, where that distance is the object distance, and this distance is the image distance, then the tangent of, say, the image angle is equal to, let's call this distance d, just for grins. It's equal to the sine over the cosine, or the opposite, d, over the adjacent, which is s, and actually, let's tangent of the angle of incidence is equal to d over s. In the same way, the tangent of the angle of refraction is equal to the opposite d over s prime. Now, that means that if I try and be sneaky, or just cleverly rearrange just a little bit, then I can say S is equal to d over the tangent of the angle of incidence. S prime is equal to d over the tangent of the angle of refraction. If I divide both of those by the other, I have that S, the object distance over the image distance, is equal to the tangent of the angle of refraction divided by the tangent of the angle of incidence. And I have from Snell's law that N2 over N1 is equal to the sine of, as I've drawn it here, that's N1, the angle of refraction, divided by the sine of the angle of incidence. And if these angles are small, we're taking an approximation right here. If we weren't going to make these approximations, if we were going to say, oh, we're looking at a tremendous angle, life would be more complicated. But for our first case, if an angle is very small, I can say that, okay, the tangent of that angle, using the small angle approximation, is approximately equal to the small is approximately equal to the sine of that angle, which means that I can say, the sine of the angle of refraction over the sine of the angle of incidence is pretty much the tangent angle of refraction over the tangent angle of incidence, or the object distance over the image distance is equal to n2 over n1 as it's drawn here.